some problem? Now? Is it clear now? No? First rotational spectra of carbon 12, oxygen 16 is observed at 3.842 semi-inverse, and first rotational spectra of carbon 13, oxygen 16 is observed at 3.673 centimeter inverse. So calculate the ratio of moment of inertia of their moment of inertia. Okay. So let us assume the moment of inertia of this molecule is ion, and for C13 oxygen 16 it is I2. Okay. So first absorption occur at what? First spectrum occur at what? Which place? So first absorption means, or first rotational spectrum means when there is a transition from 1 to 0.
0 to 1.
On to yeah, it depends upon, if it is absorption then 0 to 1. If it is emission then it will be 1 to 0. Right? So if you take absorption spectra, then it will be, you have to take 0 to 1. So according to your choice, but number will be same. So you can clearly see that corresponding wave number is given, that is centimeter inverse. So if it is from 0 to 1, then corresponding, let us assume that for this molecule the rotational constant is V1, and for this molecule it is V2. So since first absorption, let us assume that absorption case, so there is a 0 to 1 transition. So that is occurring at what wave number? This wave number. So what I can say that 2B on, right? 2B on corresponds to 3.842 centimeter inverse.
Sir, 1046.
104, yes. Similarly, 2B2. So this is first absorption 0 to 1, so it will be 2B on, right? Change in wave number, that will be 2B on. Similarly, for this it will be 2B2, it will be equals to how much? 3.673 centimeter inverse. Let us take this is your equation number 2. So if you do divide 1 by 2, then it will be how much? V1 by V2 equals to 3.842 divided by 3.673. So it will be 1.04. And B is inversely proportional. We know the B is inversely proportional to Y. I is the moment of inertia. So what I can write, if it is inversely related, then we can write from this V1 by V2, it will become I2 by I1. That will be 1.04. Is this part clear to all?
Yes, sir.
Is this part clear to all? So fast absorption means you can clearly see 0 to 1 transition. Whatever they are giving, 1 to 0, it will again be 2B. Right? If you remember the theory part. If it is 0 to 1, again it will be 2B. So you have to take positive numbers. So 2B on, I have considered for this molecule, rotational constant is B on. moment of inertia is I1 for C13, oxygen 16, I2 and B2. So absorption is happening. First absorption means it will be 0 to 1 transition, and you can clearly see that that is given wave number. So when there is a transition from 0 to 1, that wave number corresponds to 2b. So 2b on for this molecule equals to this, and similarly 2b2 equals to this. Just you have to divide, and we know that b is inversely related to I. So you can clearly see that ratio of moment of inertia of second molecule to that of first molecule will be 1.0. Okay. Shall I erase?
Yes.
Second problem. There is a hydrogen deuterium molecule. Its bond length is given 0.08 nanometer. 0.08 nanometers. I can mention here also R naught is given, that is 0.08 nanometer. Okay, and also said that this molecule shows pure rotational spectrum. In addition, they have mentioned the mass of hydrogen is 938 mega electron volt per c square. Then what is the question? Question is the difference in first excited state and ground state energy. That difference you have to calculate. So they ask what is the difference between ground state rotational, first excited state rotational energy minus ground state rotational energy. That you have to calculate. Is this part clear to all? Is the question clear to all? Okay, now you know EJ rotational energy is how much? In terms of H cross, reduced Planck constant will be H cross square by 2I J into J plus 1. Right? So if you write in terms of H, then it will be H square by 8 pi square I by, but I have written here in terms of reduced Planck constant. Now for ground state, J will be 0, obviously this number will be 0, or E0 will be 0, right? So ground state energy is 0. First excitation energy for this J will be 1. So obviously if you put J equals to 1 here, so 1 into 1 plus 2, that will be 2, and these 2 will be cancelled with this. So simply you will get H cross square by I. So what is the conclusion? The difference in that energy delta, that is E1 minus E0, that will provide you H cross square by I. Okay. Now you know that H cross in SI unit, that will be 1.05 into 10 to the power minus 34 joules second. Now if you divide it by 1.06 into 10 to the power minus 19, 1.6 into 10 to the power minus 19, then that unit will be, now joule will be converted to electron volt, and second will be as it is. Okay. So this number, if you calculate, it will be 6.3 into 10 to the power minus 16 electron volt second. Okay, so this H cross you have calculated in terms of electron volt and second. Now I have to calculate that I. So we know that relation I equals to mu R naught square. So you have to calculate now mu. So mu will be how much? So if the mass of hydrogen is this, obviously for deuterium, So mass of deuterium will be twice the mass of hydrogen, right? This thing we know. So if you
Yes,
calculate that reduced mass, it will be mH into twice mH divided by mH plus twice mH. If you calculate it, you will simply get 2 by 3 mass of hydrogen. Okay. So this thing we have calculated. Now I'll substitute everything. So the delta E will be now H cross E square. So obviously this will be 6.3 into 10 to the power minus 16 square minus 16 square, okay, divided by 2i. So 2 into, in place of I have to write mu r square, and mu I have calculated 2 by 3 mh. So 2 by 3 mh. mh is how much?
तो 2 नहीं,
Sorry,
2i का 2 नहीं होगा, 2 से कैंसिल हो गया ना पहला.
हाँ. So h cross square I 2 by 3 into sorry, mh is how much? 938, right? So it will be 938 mega. From mega I have to go to electron volt, so it will be 10 to the power 6. Okay, into c square is there, so c square will be here, because mev per c square, this c square will come here. Okay, so it will be 3 into 10 to the power 8 square. Okay, and you have r naught square. So r naught square will be how much? 0.08 into 10 to the power minus 9 square. Is this okay? Is this okay? So if you
Yes,
calculate it, around you will get 9 into 10 to the power minus 3 electron volt. Because here you have electron volt square, here you have converted to electron volt. So 1 electron volt will be cancelled, and rest of the thing in SI unit. So rest of the part will be cancelled. So this electron volt square, 1 electron volt will be here, that will be cancelled, and that will be the resultant unit. Okay. Is this part okay?
yes, sir.
Shall I erase?
Yes,
Now you have carbon 12, oxygen 16 molecule. Okay, it shows pure rotational spectrum, and first 4 line of rotational spectrum observed. So this molecule shows pure rotational spectrum, and first 4 lines of rotational spectrum is observed at 88.08 centimeter inverse, then 108.78 centimeter inverse, then on to 9 on to 9.35 centimeter inverse, and last is on 58.08 centimeter inverse. So first 4 lines observed. Then what is the question? First you have to calculate part A, you have to calculate the moment of inertia of this molecule. Part B, you have to calculate the moment of inertia, you have to calculate the bond length. Part C, you have to calculate the angular momentum L for second exciting state. Let me modify it. Angular momentum A, frequency omega, and time period t for second exciting state. That you have to calculate. Okay. So there are 4 lines they have given. So if you see in the diagram, is the question clear to all? Is this question
Yes,
clear?
sir.
Carbon 12, oxygen 16 molecules shows pure rotational spectrum, and for first 4 lines they have provided you that observed at 88.08 centimeter inverse, 108.78 centimeter inverse, then on to 9.35 centimeter inverse, and then on 50.08 centimeter inverse. So you have 4 lines. Okay.
time है
Yes,
time है
time period, capital T. Okay. Okay. So I will calculate. Let me proceed. So if you separate these 2 lines, that will provide you 2B, right? So let me check whether they are giving all are same or not. So for first this separation, let me denote this separation that is denoted by 2B, right? So let me define that is 2B on, that is corresponds to this separation on 2 and on. So if you separate it, how much you will get? 108.78 minus. So as I told you, experimentally there will be little deviation always. So you have to take, when you write 2B, you have to take average, 88.08. So how much you will get? From here, if you calculate, I have calculated it, it will be 20.70 centimeter inverse. And if you calculate the difference between these 2 lines, or separation between third and second line, and let us denote this separation factor, or that is 2B, that will be how much? 129.35 minus 108.78, right? So if you calculate it, you will get 20.57, right? Yes, 20.57 centimeter inverse. And similarly, you can see there is a little variation. Similarly, you can calculate 2B3. Okay, that will be 150.08 minus 129.35. That will provide you 20.73 centimeter inverse. So this is 2B. So what will 2B actually? That will be 2B on plus 2B2 plus 2B3 divided by 3. If you calculate it, if you substitute the value to be on this, to be 2 this, to be 2 this, here, you will get 20.66 centimeter inverse. So in terms of meter inverse, it will become 2066 meter inverse. So this is your 2B. Is this part clear to all? Is this part clear to all?
Yes, sir.
Okay. So you have calculated the 2B. Now you know B in terms of I, right? So you know that B is how much? H by 8 pi
by 8 pi square IC.
IC, right? So 2B
Sir,
will
2B. Yes.
2b will be this, right? So from here you can calculate I. I will be 2h divided by, or let me put the value here itself. So 2 into 6.6 into 10 to the power minus 34 divided by 8 into pi square 3.14 square. Then 2b was 2066, and you have c also here, that will be 3 into 10 to the power 8. Okay, so if you calculate it, you will get 22.7 into 10 to the power minus 47 SI unit, that is kg meter square. Okay, is this part clear? So this is all about your A part. Is this part clear to all? The
Yes,
question is really interesting because you have 3 parts and many parameters they have asked you. It's a compact question. Okay, shall I erase now this part?
yes, sir.
Sir, answer.
Answer 2.7 into 10 to the power minus 47 kg meter square. Okay, part B, you have to calculate what? Bond length, right?
No.
R naught. Yes.
So you have to calculate I equals to how much? Mu R naught,
Not.
right? Then R naught will be how much? Root of R I by mu, right? You know I, but you don't know mu. Then how will be the mu? Anion. So you see carbon,
Mass of
mass of carbon, mass of a carbon, here one carbon is there. So you know Na carbon will contain how many? How much gram? 12 gram.
12. Yes.
On carbon will be how much? 12
12.
by Na. So this is the actually mass of carbon here. Let us denote that is M1. Similarly, when you will do for oxygen, it will be how much? 16 by Na. That will be the M2. This is part clear to all, because here only one carbon is there and its mass number is how much? 12. So what does it mean? That Avogadro number will have 12 gram. Avogadro number of carbon atom will be in mass, in weight it will be 12 gram. So on carbon atom will have how much mass? That will be 12 by Na gram. And similarly 16 gram, any number of oxygen atoms will have 16 grams. So on oxygen atom will have mass that will be 16 by Na. So you got now mass in terms mass of these two atoms. So how much you will get if you substitute here M1 M2 divided by M1 plus M2. So can I write like this? 12 into 16 divided by 12 plus 16 into 6.02 into 10 to the power 23. Can I write like this? Can I write like this?
Yes, sir.
Is this part clear to all? So obviously that unit you will get here in gram. Is this part clear to all? Just I have substituted M1 and M2. M1 was 12 by Na. Na was Avogadro number, and M2 was 16 by Na. So if you substitute it here, the M1 M2 in terms of reduced mass, you will get 12 into 16 divided by 12 plus 16 into 6.02 into 10 to the power 23. Okay. So if you calculate it, you will get 1.13 into 10 to the power minus 23 gram. It will be G simple. Okay. So you got mass. Okay. Now you can substitute here. So what will be R naught now? So I was how much? 2.7 into 10 to the power minus 47, right? In SI unit. Now if you convert, you have to substitute that mu in SI unit, then you will get R naught in SI unit, because you have already substituted that I here in SI unit. So in that graph, it will be
Sir,
yes.
root over 2.45 into 10 to the power 24.
Okay, let me check. So if you substitute it here, so it will be 1.13 into 10 to the power minus 26, right?
23 है क्या?
Sorry,
26 कैसे है सर?
यहाँ पर ग्राम में है, इसको केजी में कन्वर्ट करना है,
ओके.
ठीक है? So now it will be how much? Anyone? So if you keep here, you will get 10 to the power. If you bring minus 26 here, it will be 10 to the power minus 20.
2.45 10 to the power
0.48 comes from.
How much? 0.48.
4.8 into 10 to the power minus 11.
4.0.48
0.48 comes.
10 to the power minus 10, right? Is this you are getting?
Yes, sir.
Yes, sir.
Okay. Everybody are getting same? 0.48 into 10 to the power minus 10 meter, right? Is this part clear?
Yes, sir.
Okay. Now, yes, any question is there? Now, last part. So, you have to calculate L, angular momentum, okay, for J equals to 2, J equals to 3, right? Second excited state, na? Second excited state means J equals to 2, because for ground state J equals to 0. So, I will calculate. So, h square by 8 pi square I into J plus 1. That is actually rotational energy. That is nothing but L square by 2I. Right? So this will be cancelled, and you will have 4 here. So if you calculate it, it will be L equals to how much? H by 2 pi into J plus 1.
4 pi है.
सॉरी, स्क्वायर रूट है ना यहाँ, फिर आपका क्या हो जाएगा? 4 by 2 pi हो जाएगा, H हो जाएगा A square root of J plus 1. Okay. So now we can calculate L, right? So L will be how much? So in place of J, for second excited state, J will be 2, because for ground state it will be 0. First excited state J equals to 1, second J equals to 2. So 2 into 3, that will be 6. So root 6 H by 2 pi. So you can clearly see that angular momentum is independent on moment of inertia. So for both A and B molecules, they have different moment of inertia, but if J is fixed for both, L will be fixed. Now, can you calculate omega? Can you calculate omega?
Yes, sir.
Omega will be how much? L by I, right? And L you have calculated, right? Can you calculate? So here, what I have written, that is the pi, right? So sorry. That will be pi, right?
Yes, sir. Right.
Okay. Can you calculate? So if you calculate it, you will get root 6. H is how much? 6.6 10 to the power minus 34 divided by 2 into 3.14 into I was how much? 2.7 into 10 to the power minus 47. Okay, so it will be 0.95, 0.95 into 10 to the power 13 second inverse. Now time period t for same state, it will be 2 pi by omega. So 2 into 3.14 divided by 0.95 into 10 to the power minus 13. If you calculate it, you will get 6.6 into 10 to the power minus 13 second. Okay, this part clear to all?
Yes, sir.
Okay. Shall I erase? So last question of today's class is, suppose you have hydrogen molecule H2. Its rotational constant is B. Now, if you replace one hydrogen by deuterium, it will be HD. HD, and you have to calculate that rotational constant of this molecule. How much will be the rotational constant now? So for hydrogen molecule, you know that rotational constant B is inversely proportional, and also given that
1 by mu.
Also given that when that molecule is replaced, there is no change in bond length. When that deuterium is inserted, there is no change in bond length. So what you can write, B is inversely proportional to mu. And for H2, let us denote that reduced mass, that is mu of H. Mu of H or mu of H2, that will be how much? Simply mH2 by 2. But if you calculate for HD molecule, let us denote that reduced mass, that is mu HD, that will be how much? So you know that mass of deuterium MD, that is twice the mass of hydrogen, right? So if you substitute this condition, you will get that reduced mass of HD molecules, that will be 2 by 3, right? 2 by 3 times mass of a hydrogen. Okay, so what I can write for hydrogen, let us denote this like this, BH2, or I have to calculate for deuterium, right? So what I can write, BHD divided by BH2, that will be how much? That will be, depends upon what, mu H2 divided by mu HD, right? Is this clear? Because B is inversely proportional to mu, so rotational constant for this molecule, let us denote this like this, BH2 here and BHD here. So rotational constant for this molecule divided by this molecule will be reduced mass of this divided by reduced mass of this, and you already have calculated it, so you will get BHD equals to how much it will be now? So 3 by 4, right? 3 by 4 BH. So there is a change in rotational constant, right? Change in rotational constant, so there will be shift in the spectrum also. Like first rotational spectrum, if you see for this molecule, it will be at 2BH2, but for this molecule, it will be 3 by 2 BH2. So there will be shift due to this isotopic effect. Okay. So this is the end. Tomorrow I'll discuss the next part. that is vibrational part. I'll do few more problems for rotational itself, because question used to ask from rotational spectra. Okay, rotational and Raman spectra. I'll spend a few minutes for this topic itself. Then I'll go to vibrational spectra. Okay. So I should stop here.
Thank you, sir.